Good morning, everyone. My name is Xiaochu Wang. I'm a PhD candidate at North Carolina State University. Today, I'm going to show you some research results. The topic is demand response and baseline manipulation. Let me first introduce the concept of demand response. Demand response is defined as the changes in electric usage by the end-use customers. In this case, when there is an emergency from the supply side and the end-use customers are stressed to reduce their consumption during a certain period of time to reduce the overall operating cost. One important concept in the demand response is the customer baseline. The customer baseline is the counterfactual consumption as if no demand response event did occur. In this figure, the red line is the counterfactual consumption. With demand response event, the customer actually reduced their consumption here, which is the blue line, because we need to determine the rebate to the customer. The baseline needs to be estimated. Here is the green line. So the green line, the difference between the estimated baseline and the actual consumption will be used to determine the rebate to the customer, because the customer has more information about their own baseline. So this arises the problem of baseline manipulation. To address this problem, we use the mechanism design concept. There are two design considerations. The first is the individual rationality. This assures that the customer can earn more with participation. The other is the incentive compatibility. This means that the customer can achieve the best result by acting to their true preference, in this case, reporting their true baseline. Based on that, we propose the self-reported baseline program. It is a finite days of a program. For each time slot, the program provider will announce the probability and the sum of the rebate information. The customer will then report their baseline, which is not necessarily their true baseline. Then program provider will decide whether this customer will be recruited or not. The customer will consume accordingly. Finally, the rebate and penalty will be determined based on the DR day information and also the customer's consumption. In terms of the result, we first convert the customer's problem into a two-stage optimization problem, with the first stage to submit the report and second is to make the consumption. We first prove that the incentive compatibility cannot be achieved because the customer's private information is unavailable. Second, to address the previous issue, we bring up the concept of near incentive compatibility. This allows the customer have a certain level of baseline manipulation. Also, we derive the condition that can guarantee this incentive compatibility. We summarize our contributions here. First, we apply the mechanism design to address the baseline manipulation. The second, we propose a self-reported baseline procedure, which is convenient and also compatible with the current DR structure. Then we prove the impossibility of achieving the incentive compatibility, but we also bring up the concept of near incentive compatibility to make this program implementable. In terms of the future work, we will first consider the customer can submit a fuzzy range of their baseline instead of having a accurate information about their baseline. Also, we will set up a reduction target for the program provider to better utilize the demand response resource. That's all. Thank you.